AP Chemistry, Unit 4.3, Representations of Reactions. So reaction particle diagrams are going to be diagrams that represent what is going on an atomic level. And when you're illustrating a chemical reaction using particulate representations, there are a few things that you need to keep in mind as you draw out your diagram. You need to make sure that you illustrate the correct state of matter with appropriate spacing in between particles. So remember that solids are tightly packed together, liquids are slightly less packed together, and gases are further apart. Aqueous solutions should include their charges, and the water molecule should be appropriately attracted to the individual ions based off of dipoles. So remember that opposites attract, and the hydrogens are partially positive, so they will be attracted to your anions, and your oxygen is partially negative, and so it should be attracted to your cations. Any precipitated solid should be placed at the bottom of the container in the image, and you should go ahead and provide a key that allows the reader to go ahead and see what exactly is going on in your diagram, what thing is what, and make sure to use distinct colors, shapes, or symbols in order to differentiate those particles further. Don't rely exclusively on actually writing out the compound's formulas and charges. Instead, use shapes and colors to help differentiate. Make sure also that you're using appropriate sizing and be consistent with your sizing for things that are the same. So same atoms, ions, or molecules should be the same size throughout your particulate diagram. And lastly, make sure to use the proper number of atoms when given a formula, or the relative concentration if you're given a concentration. So if I had the decomposition of hydrogen peroxide, my first particulate diagram, where I have my hydrogen peroxide, and then I'm going to have my second particulate diagram after the reaction, where I have water and oxygen present. So I'm keeping the relative amounts of each labeled and appropriate. So I have 2 hydrogen peroxides in my reactant before decomposition example here. And then in my product post-reaction example, I have 2 waters and 1 oxygen here. I have each of the shapes and colors labeled off to the side. So my black circles are my hydrogens and my red circles are my oxygens. If I was to do the same thing for this precipitation reaction, this double replacement reaction between barium chloride and sodium carbonate, producing the precipitate barium carbonate and still aqueous sodium chloride, I would have my initial solutions of barium chloride where they are dissolved and shown as separated out. My barium is my star, my chloride ion is my heart, and my sodium carbonate, which I just realized I accidentally made a mistake in my diagram, so I've scratched them out. My apologies for that. I'm going to have 2 sodiums and 1 carbonate, my sodiums being the blue squares and my carbonate being the purple triangle. And then those 2 things would be mixed together. After they have been mixed together in my final product solution here, I'm going to have my 2 chlorides still aqueous, still floating around, my 2 sodiums still aqueous, still floating around, and then at the bottom I will have my barium carbonate, which again is just 1 star and 1 triangle. Again, I apologize for making a mistake in my original diagram, but it's corrected now, and this is an effective particulate diagram now. Again, the barium carbonate is a precipitate, and so it should be at the bottom.